The story of exploding dots begins playing with what we call a 2-to-1 machine, written in kind of a funny backwards way. We have a row of boxes, and we put dots always into the rightmost box, with a rule that says whenever we have 2 dots in any box, they explode, they go kapow, and become 1 dot, 1 box to the left. And when we're done exploding, the code we get is how we write numbers in, well, base 2 or binary. But we could easily change the rule. We could do a 3-to-1 machine, which is how we count in ternary or base 3. We could do a 4-to-1 machine, a 5-to-1 machine. We could go crazy. We go up to a 10-to-1 machine. This is how we count in base 10. But what if we're just playing? If we did instead of a 2-to-1 machine, if we flipped it and did a 1-to-2 machine, well, this wouldn't make much sense. I mean, we put in 1 dot, it would explode, become 2 dots. Each of those dots explode, become 2 dots, and we explode off to infinity. And we never can get a code. So I'm not sure if a 1-to-2 machine is interesting or not, but I don't think that there's a way that I can really control a 1-to-2 machine. But what if we did a 3-to-2 machine? Same thing. We have a row of boxes. We put dots always in the rightmost box. But now the rule is whenever we have 3 dots in any box, they explode, they go kapow, and become 2 dots, 1 box to the left. So if we put in, well, 1 dot, nothing happens. 1 is going to stay as 1. 2 stays as 2. We put in 3 dots. We have the explosion, kapow, and 3 dots become 2 dots. Now we're done exploding. We have nothing forever to the left, and then we have 2, nothing. So I guess the code for 3 is 2-0 in this weird 3-to-2 machine. We can see here, if we put in 17 dots and do the explosions in the 3-to-2 machine, we end up with a palindrome. We end up with 2, 1, 0, 1, 2. This really does put us in base 3 halves. We really are in base 3 halves, but a base, typically we think of a base 10. For example, we can count for these 10 things, 10 symbols, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Base 2, binary, we only count with 2 symbols. Base 3, we count with 3 symbols, 0, 1, and 2, typically. So typically for a base, we have symbols or digits up to 1 less than the base. But in base 3 halves, here we're allowed to use 0, 1, and 2 is actually greater than the base, because this really does put us in base 3 halves, which is base 1.5, and 2 is greater than the base. Very interesting. Calculator.